Okay, we are now recording. We're waiting for Courtney to get in the room. He is trying to, but it looks like maybe his sound is having difficulty. And now I'm trying to see if he's here or not. I don't see him here. Okay, so maybe you'll try again later. But the question was asked before I turned on the recording. What about test 3? We're in section 5.5 right now, and either after class today or sometime Thursday, or maybe even before Thursday, I'll try to get the test 3, the chapter 5 test out there. Here's the deal with that. When I say after class today, it won't be immediately after class, because there's too many things going on now. I've got a class 15 minutes after this one, so I probably won't have time to get it out there right after class. Normally I have 2 hours in between classes, a little over 2 hours in fact, but I try to eat lunch then too. However, our furnace went out, and the guy is coming to give us an estimate on the new furnace at 1 o'clock. So once I get through with that third class at 12:45, I've got 30 minutes before the guy shows up to give me the estimate on the new furnace. I don't know how long he'll be here. Hopefully not too long, but then I have another class starting at 3:15, so I don't have, I won't have much time until late, after probably 7:45, to post the test. Now I have more time tomorrow. That's why I was sort of weaseling on that a little bit. If I don't get it posted by this evening, I'll try to get it posted tomorrow. Okay, but anyway, that's where we're sitting there. All right, any other questions? Here is Bennett trying to come in. Let me get Bennett here. Okay. Bennett is just above the blue line here. Okay. All right. I don't know if Courtney's made it in yet or not. If anyone has a way to get in touch with Courtney, tell him I've been trying to get him to come in, but it seems like he's having some problems on his end. Okay. Any other questions before we get going today? All right. If not, let me also say this. Since we've got a good number of people here, I may have to repeat this some. Hopefully you won't get too sick and tired of hearing it. I think I announced it last week, but just to make sure everybody's heard. Evidently, registration for spring term must be pretty low. Here's why I say that. They are doing a huge push to get students to register for spring term. And they're doing it this week. It started yesterday and it goes through Thursday, day after tomorrow. What they're doing is having tables set up in 2 locations, one on the Birmingham campus, one on the Bessemer campus. On the Birmingham campus, these are in that new Academic Success Center that faces Wilson Road, but there's no driveway to Wilson Road. You have to come in that little street. I think there's a light there. Come in, turn into campus, go around behind the Student Success Center, or Academic Success Center, and then park in that parking lot just behind the building. It's a pretty good sized lot, sort of spread out for quite a way there. So you got a decent amount of parking there. If it's filled up, go on down near the ACAT building or somewhere like that and park there and walk back to the building. So it's somewhere in that building. It's a big building, and I think they got a bunch of big rooms in it. I'm not that familiar with the building, so I can't tell you which room it's going to be in, but go to the Academic Success Center. Okay? Now be sure you have your mask on and have it on properly. You will not be able to, you may not even be able to get on campus without your mask on, but you certainly won't be able to enter a building without a mask on. Now, whether they're going to have any masks for people there, they may have some, but please bring your own just in case lots of people forget it and they run out and then won't be able to get in the building. So take your own mask, okay? So that's on the Birmingham campus. It's technically on the west campus, but it's right across Wilson Road from the east campus, okay? Well, down a little bit, but not too far. Okay, so anyway, that's on the Birmingham campus. On the Bessemer campus, it's in the Ethel Hall building. Now, don't confuse that with the Ethel Hall building, the nursing building on Birmingham East campus. That's not where it is. It's on the Bessemer campus, Ethel Hall building there. And if you're familiar with the Bessemer campus, there are two entrances to the campus. One is at the light right across from what is now UAB West Hospital. Years ago, it was Bessemer Caraway Hospital. Okay, there's a light there. If you go in that entrance, you have to go through a gate, and then you see a Y in the road. Take the right fork of the Y and go all the way around the A building, and here comes Courtney again, so hopefully he'll be able to get in this time. Okay, and that should get us up to let's see, 12 students maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, up to 12 students. Hopefully Courtney can get in this time. Okay, so on the Bessemer campus, Ethel Hall building, that's two entrances off the Bessemer Superhighway. The one at the light, you have to go in through the gate, then there will be a Y in the road. You take the right fork of that Y, go around the A building, and when you come back on the other side of the A building, you enter a great big parking lot at the bottom. If you go on to the next entrance off the Bessemer Superhighway, this is the one between the Bessemer Civic Center entrance and the light. There's one more entrance there, close to, within sight of the one at the light. If you go in that entrance, you're right in the parking lot you need to be, okay? And if you go in the parking lot, the Ethel Hall building is, depends on which way, it's on the south side of the parking lot, you might say. It's the newer building, and what you need to do from the student parking lot down there, walk up around the right side of the building until you come in the main doors. They face not the parking lot, but the opposite side of the building. Come in those main doors there, and immediately on coming in, the Ethel Hall Auditorium. It's not really much of an auditorium, but that's where the registration will be for the Bessemer campus, or anyone who wants to go there. There will be tables set up, and those tables, in addition to everybody being masked, there will be a plexiglass plate between the advisors and the advisees. Everybody will be social distanced, and there's plenty of there'll be people. There'll mostly be faculty members. There'll also be administrators. There'll also be maybe some staff people there manning those tables in every area you can imagine. Most of you, I imagine, are in general studies. There will be on the Birmingham campus 2 general studies stations. On the Bessemer campus 1, there will be health professions. There will be pre-nursing. There will be career technical, and probably business. On the Bessemer campus, I think there's 2 tables for career technical. Okay, so there's lots of tables. There will be tables for financial aid, tables for all sorts, anything that you would have a question about will be in that big one room, either on the Bessemer or Birmingham campus. Okay, I have something happening here, and it was only rang once that I heard, and it's a missed call. I don't recognize the number. Does anyone know Courtney's number? That would be the only reason I'd even try to answer this. If he was still having trouble coming in, I would give him a call. But
I made it in.
You made it in. Excellent. Okay, good. So I'm not going to worry about whoever that was. Okay, glad you made it. All right. So that goes from, it started yesterday, it's today, tomorrow, and Thursday, so Monday through Thursday of this week, from 9 in the morning until 7 in the evening. There will be people at all those tables there to help you, advise you, and register you. Now, remember, in this new system we have, you are the only ones that can actually register yourself. We cannot register you, but we can help you walk your way through that. And that's why they've got the table set up that way, and we can help you do whatever needs to be done. Now, in my mind, the best thing would be not to go through that. Go to the Virtual Advising Center, get your advising there, register yourself. And that way you don't have to be exposed to anybody on campus, okay? But if you really want to have or need to have the face-to-face, so to speak, then go to the one of those two buildings between 9 in the morning and 7 in the evening, today, tomorrow, or Thursday. Monday's already over, okay? Now, the Virtual Advising Center will still be open. It'll be open next week, Monday, Tuesday, and Wednesday, but only Monday, Tuesday, and Wednesday, because we have professional development then. You don't have any classes next week. And then it'll be open again the week after Thanksgiving, final exam week, and maybe even a few days into the week after finals. So you can still do it then, but try to get done now while you can, while there's all these resources available. All right, any questions on that? I'm sorry I took so much of class time, but they're really pushing this. All right, now last time we just got started in section 5.5 on our multiple angle formulas, which we did specifically double angle formulas. And here's the first example with double angle formulas. Okay, here we have 2 cosine x plus sine of 2x equals 0. Well, there's several things problematic with that equation, isn't there? First, we have 2 different trig functions. That would be almost like 2 different variables in it, and one of these is a trig function of x, the other of 2x. So what we should do here is take this sine of 2x, a double angle, and rewrite that as using our double angle formula. So we're not going to mess with this to begin with. That's 2 times the cosine of x, just write that term down, plus, now look just above, if you got your books open, your ebooks or whatever, to that double angle formula, and what is sine of 2x? Well, sine of 2x is 2 times the sine of x times the cosine of x, and then set that equal to 0. Okay? Now that actually makes it look a little more complicated. It's certainly longer, but now you can do something with this. You note that there is a common factor in both of those terms, 2 and cosine x. So factor out 2 times cosine x. That leaves you 1 from the first term, because that whole term got factored out, plus the 2 got factored out, but the sine x did not, and the cosine x got factored out. So now that simplifies to be that. Well, now we have a product of 2 entities equal to 0. Well, we know what happens with that, don't we? Either the first one, and you could say there's 3 entities, but we'll deal with that. 2 times cosine x has to equal 0, or 1 plus sine x has to equal 0. One of those two. Now they didn't give us any limits on the x's here, so we're going to assume a general solution, all real number x's that'll make this true. Well, the first place, 2 is never equal to 0. Okay, so you can divide out the 2 if you want to. Okay, that's out of there. Okay, now what that gives us is cosine x equal 0. Well, where is that true? That's true for every half pi. Okay, remember, pi halves, 3 halves pi, 5 halves pi, 7 halves pi, negative half pi, negative 5 halves pi, negative 3 halves pi, negative 7, every half pi you've got. So x is equal to pi halves plus n pi, okay? Normally for cosine we do it a 2n pi, but because this hits that every half pi, 1 pi apart, we'll put it plus n pi, where n is any integer, positive, negative, or 0. Integer though. On this one, we will subtract 1 from both sides to isolate the sign, and that gives us sine x is equal to negative 1. Well, where is that true? That's true at 3 halves pi and every 2 pi from there. But guess what? Those are all half pi's too, so this answer right here covers both these and those, because sine is negative 1 at 3 halves pi plus 2n pi. It's included in this listing. There's some things in this listing not in that one, so we'll just go with pi halves plus n pi. How did the book do on it? They listed them both separately, okay? Whereas the second one, okay, I don't know why they did it the way they did. We'll show it, but this is a simpler way to write that, okay? And we'll show how they did it. So let's clear. Any questions on this before I clear the screen? Any questions? Okay. Now, how did they proceed? Begin by writing the equation so that it involves functions of x rather than 2x, and that's what we decided to. But then they factor and solve, so they wrote it again. I don't know why, but they did. That's perfectly fine. They have all the time in the world. And then the first thing is write it so it involves functions only of x rather than of 2x. So that means expand the sign of 2x. And that would be 2 cosine x, that's what it's written down, plus sine of 2x is 2 sine x cosine x equals 0. Now that may look longer and more complicated, but it actually allows you to factor. So let's factor first. Factor out the 2 sine x from both terms. That leaves you a 1 from the first term and just a sine x from the second term. Okay, done. Now we set each of these terms equal to 0 because you're a zero product principle. If you got 2 entities multiplied together giving you 0, one of those entities has to be 0. Now you could say you have 3 entities here, 2 cosine x and 1 plus sine x. Well, 2 is never equal to 0, so you could throw that one away. It's not equal to 0, but cosine x can be. So that's what they're going to do. They're going to keep the 2 with it and just say either this one's equal to 0 or that one's equal to 0. Okay, moving to the next page. The next page, they just give you your solutions within the first period, 0 to 2 pi. Okay, and that's going to be pi halves or 3 halves pi for cosine equal to 0, or 3 halves pi for sine is equal to 0. Okay, well, guess what? If you just do pi halves plus n pi, you would count this one and that one because those are the same, and every other thing half pi that's out there. But rather than that, they do this one to be pi halves plus 2n pi, do this one to be 3 halves pi plus 2n pi. Well, guess what? If you just took out the 2 here, you get them both in one statement. But if you don't want to do that, this is perfectly correct too. Now here's the problem with that, especially for those who are WebAssign fans. WebAssign is going to give you only one possible way to write that solution, whereas in reality there are at least 2 perfectly legitimate. Like I just said, pi halves plus n pi. That covers both of these, but if WebAssign wants you to write both of these separately, it'll tell you the other one's wrong, where it will not be wrong. So just stand by and realize sometimes WebAssign, because it's a programmed thing, it can't include everything. It's not artificial intelligence. It's more artificial than it's intelligent. It's not intelligent at all. Okay, so now that was example 1. Is followed by a checkpoint. Please do the checkpoint of everything we got. Now they're jumping to power reducing formulas. That's skipping both example 2 and example 3. So let's go back to the whiteboard, unless there's any questions on this one. Are there? Okay, going back to the whiteboard, and here we'll do example 2. Says use the conditions below to find sine of 2 theta. So this is what we're looking for. I can't write. I'm just going to clear the screen. That's easier. Okay. We're looking for sine of 2 theta. We're also looking for cosine of 2 theta. And we're also looking for tangent of 2 theta. Using these conditions, that cosine of theta is equal to, this will not write equal signs well, 5/13, and this is also found in, okay, here's somebody, Kelly, must have got bumped out and come back in, because I'm pretty sure I have Kelly here. Yeah, already marked Kelly here. Okay, welcome back. Okay, the second condition is that you're here, that 3/2 pi is less than theta is less than 2 pi. Now, what does that tell you? You're in the fourth quadrant. First quadrant is 0 to pi halves. Second quadrant is pi halves to pi. Third quadrant is pi to 3/2 pi. Fourth quadrant is 3/2 pi to 2 pi. And sure enough, cosine is positive in the fourth quadrant. Okay? So, that's what you know, and you're looking for sine of 2 theta. Okay? So let's say what the sine of 2 theta is. From the previous page, you know, and the previous example, you know it's 2 times the sine of theta times the cosine of theta. That's your double angle formula for sine. Now, we know what cosine theta is. This is 5/13. Okay? We don't know what sine of theta is. So that's where I find it's useful to draw you a circle. Okay? And then put a set of axes through that circle. Okay? Now this circle is not a unit circle. What I want this circle to be is a 13 circle. Okay? Whoa, that's a lot. So let's see if we can figure that out. That would be half of 13 would be between 6 and 7. So let's do that is 6, that's 7. So if that's 6, that would be 3. There would be 1, 2, 3, 4, 5, 6, 7. And then halfway between 7 and 13 would be 10. And there's 11, 12, and there's 13. And this would be 7, 8, 9, and then 10. Now that's pretty messy, isn't it? But there's a 13. Let's do it. Now we're in the fourth quadrant, so let's do it for here too. So if this is your 13 here, there would be 6 and 7 there. There would be 3, 1, 2, 3, 4, 5, 6, 7. Let's put 10 halfway in between there, and that would be 11, 12, and 14, 15. Wait, I got that wrong. Anyway, there's your thing. Now, cosine is 5/13. Well, 5 is your adjacent side. There's 1, 2, 3, 4, 5. So that would be there. And so 5/13 would be here. Okay, 5 is your adjacent side. Your 13, it's somewhere down here. Okay, so there is, this is so aggravating. Okay, 1, 2, 3, 4, 5, come down here. There is your point. Okay, and so this would be, the length of this is 13, that's your hypotenuse, and the length here is 5. Okay, so this would be your angle theta. It's actually the angle going around here, but it's also its reference angle would be this one right here. Okay, so we've got to figure out what in the world your sine is. Now, you didn't have to do this. That's not necessary. This just helps me to see it. Okay, well, if we know that sine squared theta plus cosine squared theta is equal to 1, don't we? Cosine theta is 5/13, and if I were to square that, this is going to be, well, and I also need to square sine squared theta. That's equal to 1. Well, 5/13 squared is going to be 25. I think that's 1/69. Someone check me on that, but I believe that's right. So let's make this 1/69, 1/69. That's also 1. Okay? Now, and then we have that sine squared theta plus this is equal to that. So what we're going to do is subtract 25 1/69 from both sides. Okay, that goes to 0. This gives you 144 1/69. That's sine squared. So that indicates that sine of theta is, now, when we take a square root, you have to include plus or minus. I'm going to leave that off for right now. Let's just do it. That was to be the square root of 144, which is 12, over the square root of 169, which was 13. Okay, now let's decide what sign we give it. Well, you're down in the fourth quadrant. Sine is negative down there. Okay, so we've got what sine is. So now we can say this is, if I can get my pen to write, is equal to 2 times a negative 12/13 times what was given to begin with, 5/13. So what would this be? Sine of 2 theta would be negative 2 times 5 was 10. That's a negative 120 1/69. We already know 13 times 13 is 169. So there we've answered the first one. Sine of 2 theta is minus 120 over 169. Nice round number, right? Well, what's cosine of 2 theta? Well, I think I'm going to erase some of my work here because I don't have room to write everything. So let's erase, if I can get the eraser to work. I know it's a beautiful circle, but we're going to have to do away with it, I think. Okay, so let's do away with it. That was so much fun writing it. But remember how it looks, because we will be using the concept of that as well. Okay, so let's get back to our draw mode. Now let's do cosine of 2 theta. Now there's several ways to express cosine of 2 theta. Actually, the easiest one, though it's a little harder to remember, and if you need to, flip back a page and look at it, and cosine of 2 theta actually is going to be easiest done as 2 times the cosine squared u minus 1. 2 times cosine squared u, squared theta, minus 1. Okay? Flip back a page and you see it there. We went through this last time, how we got those. Okay? But that's going to be the one easiest to use, and here's why. Because they gave us what cosine was. This is going to be 2 times 5/13, they gave us that, squared minus 1. Well, this is going to be 2 times 25 over our good old 169, but then we're going to be subtracting 1, so let's go on and do it as 169 over 169. Okay? Well, 2 times 25 is 50, so this will be 50 over 169 minus 169 over 169, and that, I think I'm going to have to erase this part too. Don't think we don't need this anymore, but let's see. Hopefully you remember all of that too. If not, I'll say, and this is left to the student, you know, because you'll be able to do that, and that's how instructors get away with not knowing how to do something. Okay. Okay. So let me get my pen back. Okay. Now, what would this be? This is negative 119 over 169. So that I don't think can be reduced any. The sine of 2 theta was negative 120 over 169. The cosine of 2 theta is negative 119 over 169. Okay. Now, the third thing to ask for, so now we've got cosine of 2 theta taken care of. If I could find my check mark, there it is. Now let's do tangent of 2 theta. Now, if any of you are wanting to go back to your double angle formula and look at that, forget it, folks. Okay? Do what's easy. Tangent is always sine 2 theta over cosine 2 theta. Our good old ratio identity or quotient identity. And sine of 2 theta was negative 120 over 169, and cosine 2 theta was negative 119. Awfully close, aren't they? Over 169, and the 169s can be divided away or multiplied away by multiplying the numerator and the denominator of 169 over 169. They'll go away, and this leaves us with minus divided by minus is positive 120 over 119. And there's your tangent of 2 theta. We really don't need this one anymore, so I'm going to get rid of it just because it's in my way. And there's your 3 answers. Okay? Tangent of 2 theta is positive 120 over 119. And not only that, you know where you are, don't you, Waldo? If sine of 2 theta is negative, cosine of 2 theta is negative, tangent 2 theta is positive, you better be in the third quadrant. And if you think back to my thing that I said, remember how it looked. Remember that was just barely in the fourth quadrant. That was your theta. If you roll that around again, sure enough, you're in the third quadrant, and you're almost on the bisecting line of that quadrant. 120 over 119, you're right. Very close to 2 theta would be awfully close to 5 pi over 4, 5/4 pi. Not quite, but awfully close to that, just a little beyond that. Okay, so there are our 4 solutions. Let's see what they got in the book. Negative 120 over 169 was sine of 2 theta, good for them. Negative 119 over 169 was your cosine 2 theta, and the tangent 2 theta, rather than trying to mess around with, oh, and they did it. Oh, I can't believe they did it. They went back and figured out what tangent theta is based on our triangle. You see, they use that same, they didn't draw the circle, but they basically used the drawing to be very similar. And then they put all that mess together, all that extra work. All you had to do was divide sine 2 theta by cosine 2 theta, and you get 120 over 119. Folks, do whatever makes most sense to you. If that made the most sense, go the way they did, okay? Otherwise, go the easy route, okay? Now, as all examples, they are followed by a checkpoint. Please do the checkpoints. All right, they also skipped example 3, bottom of page 382, so let's do example 3. Any questions on this one before I clear it? Any questions? Okay, so I'm going to clear the drawings there. Let's do example 3. Rewrite. This is such a pain in the neck. The pen will not write sometimes and then write before you even touch the board. Okay, so it says rewrite sine of 3x in terms of sine x. Now I'm going to shorten that. ITO means in terms of sine x. Okay, now that's going to take a little bit of effort. Not too bad, but a little bit. Well, we don't have a rule for a triple angle, okay? We're dealing with multiple angles, so this is very legitimate in this section, but we don't have a rule for that yet. But let's see what we do have a rule for, okay? We know that sine of 3x is the sine of x plus 2x, right? Because x plus 2x is 3x, right? Well, we also know what a sum of sine formula is. Okay, that is sine of the first, that's x, times cosine of the second, that's 2x, plus cosine of the first, x, times sine of the second, that's the 2x. Okay, this looks way worse than what we started with. We want it only in terms of sine x. Well, there's a sine x and there's a sine 2x. We've got problems, don't we, Houston? Well, let's continue. What is cosine 2x? In terms of sine x? Oh, turn back one page and you'll see there's the third formula for cosine 2x is right there as 1 minus 2 sine squared. They use u, we're going to use x. So this will be a sine x, that's already in terms of sine x, that's fine. And this one will be, what do we just say? 1 minus the 2 times the sine squared of x. 1 minus 2 times sine squared x. So now we've got this whole term here in terms of sine x. No cosine there anymore. Plus, But here we got a cosine, so we're stuck with it for now. Cosine x times the sine of 2x. Well, we just have done that a couple times now. That's 2 times the sine x times cosine x. We did it in example 1, and I think we did it in example 2. There's what that is. Well, let's combine things together. Whoa, 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 here's Courtney. He must have bumped out again and has come back. Glad he made it back. Let me get him in here. Okay, I'm sure I've already got him on the roll. All right, let's combine some terms where we can. This will be distribute the sine x here across the parentheses. That gives us sine x minus 2 times sine cubed x. That's still in terms of a sine x. Now here we're going to multiply this into there, and this will be 2 sine x times cosine squared x. Okay, now what's wrong with this picture? That we wanted this in terms of sine x. Here's you have a cosine x. But guess what? We know what cosine x squared x is in terms of sine is 1 minus sine squared. Remember our Pythagorean identity that sine squared x plus cosine squared x is equal to 1. Okay, so now if we distribute that, this gives us a sine x, that's in terms of sine x, certainly, minus 2 times sine cubed x, that's in terms of sine x, plus, now here we have a 2 sine x times 1, so there's a 2 sine x, if you distribute that in, and then here, distribute that in there, and you have a minus 2 sine cubed x. Okay, so let's combine some like terms here. Here we have sine x plus 2 sine x, that's 3 sine x, and here you have a minus 2 sine cubed x and another minus 2 sine cubed x. That would give you minus 4 sine cubed x. Done. We've now expressed sine of 3x in terms of sine x only. 3 times sine x minus 4 times sine cubed x. Let's see how the book did, and I think that's what they got. 3 sine x minus 4 sine cubed x. All right. Any questions on that one? Okay. And the checkpoint here is to rewrite cosine 3x in terms of cosine x. And guess what? I don't want to say you can do them all, but you can use this kind of a procedure to get most of your multiple angle formulas in terms of single angle formulas. Now you don't always want to do that, but sometimes you do. Okay? Any questions? All right. Then I think I'll go back to my whiteboard, to my PowerPoint. And we're in 5.5, so I think that's it right here. And for some reason, oh yeah, resumes the slideshow. Okay, and that's where we left off example 1. And we did 2 and 3, so let's move to power reducing formulas. Now this is a rather strange, at least I found it a little strange, to call them this, though it certainly is exactly an accurate description of what's going on here. You are reducing powers from squares to single powers or whatever. Okay? But we really, uh-oh, here comes Jared. Good deal. Jared's here. Okay, let me get him marked. if I can do it without dropping the whole shebang here. Jared is one of the blue lines, so he's right there. All right, we're just missing Damien, Jalen, and Sharika. So good attendance today, folks. Okay. Now I'm going to pause for a moment here because we've had some people coming in and going out. I want to make sure everybody heard it. This week, Monday through Thursday of this week, they're having a very big push to get as many students from this term registered for next term. Okay? This is happening on both campuses, Birmingham campus and Bessemer campus. On the Birmingham campus, it's in that new Academic Success Center that faces Wilson Road, but you can't enter the building from Wilson Road. You have to drive in that road on the right hand, well, on the side of the building at the light, come in that road, curve around, and park behind the building. The Academic Success Center is a big building, and I'm sure it has lots of big rooms in it. One of those big rooms, maybe in more than one, they're going to have set up with tables, plexiglass between the advisors and the advisees. Everybody will be masked, and you can get all the help you need. Everything will be social distanced. You won't have to be close to anybody, and you'll have plexiglass between you and the person you're closest to, the advisor. So you should be able to get all your advising done and probably help with your registration. Remember, in this new system, this banner system, we cannot register you. You have to register yourself. But you can be right there with the advisor, close enough to see what you're doing, and they can help you get registered. Okay? That's on the Birmingham, technically on the Birmingham West campus, but it's right across the street from the Birmingham East campus, or across Wilson Road. On the Bessemer campus, it's in the Ethel Hall building, and that's not to be confused with the Ethel Hall Nursing Building on the Birmingham East campus. That's not where it is. It's on the Bessemer campus, Ethel Hall building, and there you can enter the Bessemer campus from one of two entrances. One of them's at the light where the UAB West Hospital is. It used to be Bessemer Caraway Hospital a long time ago, but for those who knew it that way, that's where it is. If you go in that entrance, you have to drive. When you go in through the gate, take the first right at the fork, go all the way around the A building, that's that big building in the middle, and come out into a parking lot, and the parking lot is down the hill from the Ethel Hall building. It's outside that loop that you just made. Okay, if you go to the entrance in between the Bessemer Civic Center and, oh, here comes Azora. Let me wait and say all this again when I get Azora in the room, okay, so to speak. So Azora is here. Miss seeing that she wasn't here before, okay? So here's Azora. So now we're only missing Damien, Jalen, and Sharika. Okay, so at least everybody's getting to hear this. Let me start over Azora just for you. No, there's a couple of people that just come in. There's a big push going on this week, Monday through Thursday of this week, to get everyone registered for spring term that we possibly can. And that will be done on both the Birmingham and Bessemer campuses, Monday through Thursday, from 9 in the morning till 7 in the evening. There will be either a faculty member, an administrator, or a staff person sitting at every one of the desks that you could need somebody to be at. That could be general studies, 2 tables on the Birmingham campus, 1 on the Bessemer campus, career technical, 1 on the Birmingham campus, 2 on the Bessemer campus, pre-nursing, 1 at each campus, health professions, 1 at each campus, business, 1 at each campus. Whatever area you're in, there's going to be a table there for you, sometimes two, okay? There'll be an advisor, one or more advisors on one side of the table, plexiglass in between. Everybody will be masked, and you can get advisement and help with registration, but you still have to register. Remember, we cannot register you in this new banner system. You have to register yourself, but they can be there watching. Now, I'm not going to be on either campus any of the days because of my health situation, okay? But there will be people there taking care of students, okay? There will be financial aid desks somewhere in that same room. There will be whatever else you might need. Records office, somebody from any office you need help from, they'll either be in the room or reachable by phone from that room, okay? So please, if the best thing for you to do would be to go to your virtual advising center, get advisement there and register yourself. That way you don't have to be exposed to anybody. But if you need help that you don't feel like you can get through the virtual advising center, or whatever, you just want to have someone looking at what you're doing, you can go to either campus, Ethel Hall building on the Bessemer campus. Now, if you go to Ethel Hall building on Bessemer campus, like I was describing, the parking lot is right down there off the Bessemer Superhighway, and that's the entrance that's in between the Bessemer Civic Center and the light that also is the entrance to the hospital, UAB West or Bessemer Caraway it used to be. If you go to into that parking lot, the Ethel Hall building is just to the south of that parking lot. Walk up around the building and come in the glass doors coming back. The entrance from the parking lot is down in the basement level, okay? If you can go in there, it's perfectly fine to go in there, but you have to wander around that area finding either the elevator or the stairway, and then go up to the main level and then finding your way to the auditorium. Now, it's not hard. It's not that big of a building, so it's doable. But if you walk around the side of the building and come in the glass doors, and once you come in the doors, the auditorium is right there on your left, just right on your left when you come in those big glass doors. So that's the easiest way to get in there. Save you having to find stairwells or elevator and go up and then finding your way around to the building. You go in the doors that's right there, the upper part. All right. Any questions then on making use today, tomorrow, and Thursday from 9 in the morning till 7 in the evening? Get registered if at all possible. Again, my advice would go to the Virtual Advising Center, get registered. You'll have to register yourself no matter where you are, but if you can get your advising done through Virtual Advising Center, then go to and register yourself. That would be the way to go, and you don't have to be face-to-face with anybody. But if you need that face-to-face, go to one of the two campuses. All right. Okay, I've said that a few times now. Let's move on to power-reducing formulas. For those who have just come in, we're in Chapter 5, Analytic Trigonometry, 5.5, multiple angle and product of sum formulas, and we've just finished the multiple angles, and we're moving to power-reducing formulas. And this is on page 383 in your text or ebook. Now I can't get this to advance. Okay, there. The double angle formulas, those that we used before, can be used to obtain the power reducing formulas. Now I want to show you how to do that real quickly. The double angle formulas. Let's go back to them quickly here. If I can find my pen. I've got it in my hand, but I can't. Oh, there it is. Okay. So let's review what those double angle formulas are. Okay. Cosine of 2u you could write in one of three different ways. One was cosine squared u minus sine squared u. Now, we didn't use that on either of our last two examples. Okay, the second way was cosine 2u. This is so aggravating. Cosine 2u is equal to, and if you need to, turn back a page and look. It's either 2 times the cosine squared u minus 1, or it's also cosine 2u, happy cosine 2u, is equal to 1 minus 2 sine squared u. Okay? One of those, all three of those are your double angle formula for cosine. Okay? Notice we're not really using sines or tangent, just the cosine double angle formula for cosine. Now, to get the power reducing formula, what you do is take this one right here and solve for sine squared u. So first thing we're going to do is subtract 1 from both sides. That get rid of your 1 here. And then we're going to divide by negative, okay, let's write it out. Cosine 2u minus 1 is equal to minus 2 sine squared u. Okay, divide both sides by minus 2, and you get, I'm going to rearrange the order here, sine squared u is equal to, and when you divide by minus 2, that would make this 1 over 2 minus, and they write it all over this, so let's just do 1 minus cosine 2u, okay, over 2. And that's exactly what they get here. 1 minus cosine 2u over 2. Now, doing that same thing here, you would get, solving for cosine squared, first thing you would do was add 1 to both sides, and that would give you 2 times cosine squared u is equal to cosine 2u plus 1. Then divide by 2, and you get 1 plus cosine 2u over 2, which is exactly what you get here. And then, rather than using anything else, just do tangent squared u would be the quotient of sine squared u over cosine squared u, your ratio or quotient formula. Okay, the over 2's would disappear. You get 1 minus cosine 2u over 1 plus cosine 2u. So those are your power reducing formulas. That if you had a squared term and you didn't want a squared term, you could get it in terms of cosine 2u. Okay, everything's in terms of cosine 2u with those power reducing formulas. All right, let's move on. Now I have, my phone is on charge, so I'm going to have to use my, my watch is on charge, so I'm using my phone as my timekeeper. We have about 10 minutes left, so let's see what we can do. Here's example 4, reducing a power. Write sine of sine fourth x in terms of first powers of the cosine of multiple angles. So here we're going from a high power to a first power. Okay, well, what in the world is sine to the fourth of x? Well, that's the same as sine squared of x squared. But we know what sine squared is in terms of lower order of cosine multiple angles. And that was your 1 minus cosine 2x over 2. Okay, flip back to what we just did, and that would be squared. Okay, but you still have high power angle. They're not first powers because you got to square this. So what would that be? The square of this would be 1 minus 2 cosine 2x plus cosine 2x squared over 4. Okay, because you squared numerator and denominator. Well, this is okay. This is okay. That's okay. That's not okay because you want first powers of cosine of a multiple angle. But now we can use our cosine one. So I'm going to rewrite the first part of this. 1 minus 2 cosine 2x. That's all good. Plus, now let's do this one. Cosine squared of an entity would be 1 plus cosine of twice that, which would be 4x over 2. Okay? And all this is over 4. Okay? Now that was your power reducing formula from cosine 2x to cosine 4x. This is cosine squared of 2x, cosine 4x there. Alright, now this makes for a little bit of a mess here because you got denominators both places. So why don't we make this over 2, and that would make that a 4, and put this over 2 and make that a 2 over 2. Okay, that would be 1. Alright, and now bring that denominator down here and make it a 4. Okay? 2 times 4 is 8. So this would be 2/8 or 1/4 minus I think I'm going to leave that there. 1/2 cosine 2x plus, this one will be in eighths, 1/8. I wish I'd left that one alone then. Plus cosine 4x over 8. Okay, so 1/4, which is 2/8, plus 1/8 is 3/8, minus 1/2 cosine, let's just write that as cosine 2x over 2 plus cosine 4x over 8. So there we've done it. We've rewritten the sine 4th x in terms of first power of cosine of multiple angles. This one's a 2x, that one's a 4x. This is just a constant. Okay? So that's how we did it. Let's see how they did it. They factor out a 1/8. So let me do that as well, just so you'll see how to do that. If I could find my pen, there it is. So factor out a 1/8. Okay? And what does that leave us with? A 3 here minus, and to get this to be an 1/8, we multiply by 4. 4 times the cosine of 2x, and this would be just plus the cosine of 4x. Okay. Now, don't think anyone else is coming in. I think that just popped up. So that gives you 1/8 times 3 minus 4 cosine 2x plus cosine 4x. That gives the same answer. Let's see, with 4 minutes left, let's see if we can erase what I've got. Anyone have any questions before I erase this? Any questions at all? Okay, so let's erase that. Let's see how they proceed. Note the repeated use of the power reducing formula. First we'll do sine of fourth x is sine squared of x squared. They wrote it, I think, similar to what I did. And that would be sine squared of x is 1 minus cosine 2x over 2. And that thing squared, when you square numerator and denominator there, the 1/4 comes on the outside and you're left with 1 minus 2 times cosine 2x plus cosine squared 2x. This is just squaring a binomial. Square the first term, twice the product of the two, that's minus 2 times cosine 2x, and then square the last term. Okay, this still has a square in it. That term's fine, that term's fine, but this one still has a square. So do it again. But this time you're doing cosine 2 squared 2x, and that would be, so the 1/4 out front, the 1 minus 2 cosine 2x, plus that cosine squared 2x becomes 1 plus cosine 4x over 2. Okay, and then if you pull out the 1/2 here, which leaves you a 4 here then and a 2 here then, okay, well, they do it a really strange way. They go back and multiply back in again, which is fine. It's perfectly fine. This would be 1/4 times 1 is 1/4. 1/4 times 2 cosine 2x would be a minus 1/2 cosine 2x. Okay, then this gives you a 1/4 plus 1/2. That would be, no, I'm sorry, they leave the 1, yeah, 1/4 times 1/2 is 1/8. Okay, and 1/4 times this would be 1/8 of cosine 4x. Okay, then they combine like terms, and that gives them 3/8. I think they do. Yeah, 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. Now they go back and factor out the 8 again, which seems like they're running around their elbow to get to their ear. But let's see what happens when they factor out the 1/8. That leaves you a 3 here, a minus 4 there, okay, because 4/8 is 1/2, and a plus cosine 4x here. Again, this is the type of thing that WebAssign and places like that are going to look for one and only one answer. This answer would have been perfectly fine, or this answer, either one, but they're probably only going to look for one. So if you're doing WebAssign, be ready sometimes for them to tell you got a wrong answer when it's a perfectly correct answer. It just happens. All right. You can use a graphing utility to check that result. You can plug in sine 4th x here, and when you plug in this other function here, 1/8 of 3 minus 4 cosine 2x plus cosine 4x, and you'll see they both plot on the same line, same curve. So they are the same. Their graphs coincide. Now, are we ready for half angle formulas? We are, but there's no time. The reason there's no time is 11:15. So we made it to top of page 384, half angle formulas, right there. Sorry, we didn't get any further. I had to go over, or I chose to go over that advising registration thing several times, so we'll be beginning there next time. Do you want me to put out the test early or wait until after we finish this next time? Which would you prefer? I hear no answer. We'll talk about it. Well, let me know if you want it put out before Thursday. Otherwise, I'll put it out Thursday after we finish class on Thursday. Homework exercises here would be any of the odds, 7 through 13. They're all at Calc Chat. 9's at Calc View. Any of the odds 15 to 19, they're all at Calc Chat. Any of the odds 21 to 20, either 21 or 23, both at Calc Chat. 21's at Calc View. 25 should be at Calc Chat. Any of the odds 27 through 33, they should all be at Calc Chat. 27's at Calc View. 35 to 39 should all be at Calc Chat. 37's at Calc View. 41 or 43 are, whoa. I'm sorry, stop at 33 because the rest of them are using half angle formulas. So we'll come back and pick up those later. So any of those up till 33, and we'll pick up the half angle formulas once we do this. So this is all on page 388. Okay. In fact, the left-hand column of 388 is where you'll find those exercises. And once we finish the rest of the section, we'll then the rest of 388 and 389 will be up for grabs. Okay. So does anyone want me to put the test out early, or you all just assume wait till Thursday and I'll put it out then?
I think Thursday's fine.
Say again? Thursday will be fine? Okay, and that'll give you a free week, you know, of Thanksgiving to work on it as well. Okay. All right, well, I'm going to have to stop sharing because I have another class starting in less than 30 minutes, I think. I mean, less than 15 minutes. Yeah, it starts at 11:30. So I'm going to stop sharing now unless there's any last questions, anything? Okay, well, then I've already got some people leaving, so I'm going to end the meeting for everybody. We'll see you on Thursday. Okay, good deal. See you then.